battery looks something like this. This is a lead-acid battery. We call it a lead-acid battery because inside the unit are lead plates, which are submerged into an acid. This creates a chemical reaction, which releases energy and provides us with a voltage and current. The battery is therefore storing energy in the form of chemical energy. It does not store electricity. This chemical energy is converted into electrical energy whenever we need it. This battery is also rechargeable. If we supply the battery with electricity, then we can reverse the chemical reaction and recharge the battery. These types of battery provide large amounts of current, especially compared to the typical smaller household alkaline batteries. We have covered how alkaline batteries work in our previous video. Do check that out, links can be found in the video description down below. The typical car battery is found in the engine bay of the car. The battery is first used to start the engine, and it does this by providing electricity to a small electrical motor known as the starter motor. The starter motor engages a small gear onto the flywheel of the engine. It turns this to turn the crankshaft, which starts the combustion engine. The small gear then disengages and the engine runs by itself. The starter motor needs to provide a huge amount of force to be able to turn the flywheel. So the starter motor will draw an extremely large current, possibly hundreds of amps, but this is only for a few seconds. This large current demand is going to reduce the energy storage of the battery, so we will need to top this back up. Connected to the engine is an alternator. The alternator is rotated by the engine, and as it rotates, it generates electricity. This electricity is fed back into the battery to recharge it. While the engine is running, the alternator recharges the battery, but it also provides the electrical power for things such as lighting and the music system. When the demand for electricity in the car exceeds what the alternator can provide, then the battery will provide this additional power, which again drains the battery. If the engine is switched off, the alternator stops rotating and recharging the battery. So the battery will provide the full electrical power to the car until it's dead. At this point, the battery can't provide enough electricity to start the engine, so we will need to jump-start the car. Let's have a look at the main parts of a car battery and then we will understand how it works. First of all, we have the plastic case which holds all the internal components in place. On the top, we have the plastic lid, and there are two terminals, a positive and a negative. By removing the lid, we can see inside. Notice the casing is divided up into 6 separate chambers, each separated by a plastic wall. Each chamber is known as a cell. Each cell generates around 2.1 volts of DC or direct current. Each cell is connected in series. The negative of one cell is connected to the positive of the next cell, to give us a total voltage of around 12.6 volts. It's the same as if you connected household alkaline batteries together. The voltages add together to provide a higher total voltage. Each cell in the battery is connected via a plate strap. This is made from lead. These straps are welded together through the plastic wall to form the connection. As we look at the battery from this view, we see that current flows through the battery cells from the positive to the negative, and that's using conventional current theory. But what's actually happening is the electrons are flowing in the opposite direction, from the negative and to the positive. But we'll cover that and you'll see why a little later in this video. Notice there are 2 plate straps in each cell, one positive and one negative. These are called plate straps because each strap is connected to a number of plates, which are sheets of lead. The plates are formed into grid-type structures, which maximizes the surface area. The grids are coated in a paste of lead oxide. The paste is where the chemical reaction occurs, and we'll see that a little later in this video. The paste acts a bit like a sponge and is going to absorb some of the electrolyte liquid, which improves the battery performance. The size of the plate determines how much current a battery can provide, but it doesn't change the voltage. The materials used for the chemical reaction and the number of plates determines the voltage produced by each cell. The grid holds the paste in place to ensure a uniform current distribution across the plate and helps to transport the electrons out of the battery and around the car's electrical circuit. The negative plate is the anode, and this is a plate of pure lead, although some small amounts of additives are added to harden the lead and protect it from corrosion. The positive plate is the cathode, and this is made from lead oxide. The plates are made of dissimilar materials to form the chemical reaction and release the electrons. Now, we don't want the positive and the negative plates to come into direct contact with each other, because this would short-circuit the battery. So, instead, we place each positive plate into an envelope separator. This is just a porous material that allows ions to flow through it without the materials coming into direct contact with each other. The positive and the negative plates will sit between each other with a small gap in between each plate. The chamber is then filled with an electrolyte liquid of sulfuric acid and water. Hence, the battery is called a lead-acid battery. I want to quickly recap on the fundamentals of electricity so that you understand the next part of how the battery works. Electricity is the flow of electrons in a circuit. We need lots of electrons to flow in the same direction through a wire so that we can place things in the path of the electrons, such as light bulbs. The electrons will therefore have to pass through this, and as they do so, they will produce light. When lots of electrons flow in the same direction, we call this current. Every material is made from atoms. The atoms have different numbers of protons, neutrons, and electrons, which is what makes them a different material. Some materials, like copper, have an electron which is free to move to other atoms. If we connect a power supply, such as a battery, to the copper wire, then the voltage of the battery will push the electrons and they will rush to get to the positive terminal of the battery. Now, I just said that the electrons flow from the negative to the positive. This is known as electron flow. It's a theory of how electricity works, and it's what's actually occurring. But you might be used to seeing conventional current, which is from positive to negative. This is the original theory, which is known as conventional current. This theory was proved wrong by Joseph Thomson, who discovered the electron, and he found that they flowed from the negative to the positive. However, we still to this day use conventional current theory when designing electrical circuits. So, if we looked at this simple circuit, we must always assume that the current is flowing from the positive and to the negative. But engineers and scientists know that electrons are actually flowing in the opposite direction. The electrical formulas we use will still come out with the same answers regardless of which way the electricity is flowing, so it doesn't really matter. There are two types of electricity: DC direct current, which we get from batteries. The electrons in this type are pushed in one direction, so it's called direct current. Think of this like water flowing down a river. The other type of electricity is AC, or alternating current, which is what you get from the power outlets in your homes. In this type, the electrons are pushed and pulled forwards and backwards. Think of this like the tide of the sea flowing in and out between its maximum high tide and its maximum low tide. When we mix certain materials together, we can cause chemical reactions. This is when the atoms of one material interact with the atoms of another material. During this interaction, atoms will bond together or break apart. Electrons can also be released or captured by atoms during this reaction. When we talk about atoms, you will usually hear the term ion used. An ion is an atom which has an unequal number of protons or electrons. An atom has a neutral charge when it has the same number of protons and electrons, because the protons are positively charged and the electrons are negatively charged, so they balance out. If the atom has more electrons than protons, then it's a negative ion. If the atom has more protons than electrons, then it's a positive ion. Rather than trying to understand this complex construction, we're going to simplify it down to this simple model of a cell with a single cathode and anode. In this cell, we have the electrolyte liquid, which is 1/3 sulfuric acid and 2/3 water. We have the positive electrode, which is the cathode. This is made from lead oxide. We then have the negative terminal, which is the anode. This is made from pure lead. When these materials are combined, we're going to get a small chemical reaction between the atoms. I'll show the atoms of these materials with these colored spheres. The positive cathode terminal of lead oxide is going to react with the sulfate in the electrolyte. This will form a layer of lead sulfate on the cathode terminal. During this reaction, an oxygen ion is ejected from the cathode and into the electrolyte. Once in the electrolyte, these oxygen ions will combine with the hydrogen ions to form water. At the same time, the lead atoms on the anode are going to react with the sulfate ions in the electrolyte. This reaction will create a layer of lead sulfate around the electrode. During this reaction, 2 electrons are released and collected in the negative terminal. So now we have a buildup of electrons on the negative terminal. As electrons are negatively charged, this means we have a difference in charge across the 2 terminals, and we can measure this with a voltmeter or a multimeter. If you think about a magnet, the electrons are negatively charged, and so they repel each other. These are attracted to the positive terminal, which has less electrons. However, they can't reach this yet. So if we provide a path for the electrons, such as a wire, then the electrons will flow through this to get to the positive terminal. We can then place things such as a lamp in the way of these electrons and use them to do work such as illuminating the lamp. While the path exists, the chemical reaction continues. But this won't last forever. The chemicals required for the reaction will run out. The acid becomes diluted and weaker, and a buildup of lead sulfate coats both of the electrodes. This means the materials of the electrodes are becoming more similar, and so the chemical reaction becomes harder to achieve. But luckily, this chemical reaction can be reversed. So if we supply the battery with electricity from the alternator, we can start to reverse the reaction. The electrons enter the negative terminal and rejoin with the lead sulfate, releasing the sulfate into the electrolyte to leave just lead on the negative plate. The sulfate ions enter the electrolyte and combine with the hydrogen ions to release the oxygen ions, and so the electrolyte acid becomes stronger. The oxygen ions combine with the lead to create lead oxide, and this releases the sulfate back into the electrolyte, making it even more stronger. If we were to leave the battery to fully discharge for too long or too many times, it becomes very difficult to reverse the chemical reaction. Additionally, the sulfate layer could break away from the electrodes and accumulate at the bottom of the battery. This means it will no longer participate in the chemical reaction, so the battery needs to be repaired or replaced. So, when we look at the battery, this chemical reaction is occurring between every plate in every cell to provide the hundreds of amps of current to start the motor and also provide the voltage to power the lights, etc. This is then recharged by the alternator. To test the voltage of a car battery, we simply switch to the DC voltage setting on our multimeter, and then connect the red lead to the positive and the black lead to the negative. We should see a voltage of around 12.6 volts. If it's below 12, then the battery is not functioning properly. By the way, if you don't already own a multimeter, then I'll leave a link in the video description down below for which ones I recommend and from where. When we start the car, the voltage will drop because the starter motor is pulling a huge amount of current. The voltage will drop to around 11 volts. If it drops below 10, however, then the battery is not functioning properly. Once the engine is running, the alternator should be generating electricity, and so we should see a higher voltage of around 14 volts. That's because the alternator is recharging the battery and the voltage needs to be higher to help force electrons back